In section 16.4, we're going to look at how to understand pH and pOH, learn how to find the pH and pOH for various solutions, and use a calculator to find the pH, in addition to learning about some different methods for measuring pH. And then we will talk about how to calculate the pH of strong acids in the next lecture. So the pH scale, let's move this over here. pH scale. The P scale is used to express very small numbers. So pH is the negative log of the H plus ion concentration. So all I need to do in order to find the pH is to take the negative log of the hydrogen ion concentration. You would do this on your calculator by pressing the negative sign or the plus minus sign, the log key, and then enter whatever the concentration of the hydrogen ion is. The number of decimal places for a log needs to be equal to the number of significant figures in the original number. So these are the number of sig figs in this hydrogen ion concentration, which is 2. So we need to make sure that we have 2 decimal places past the decimal point when we give the pH value. So the negative log of 1 times 10 to the negative fifth is pH of 5. Here's a copy of a pH scale showing the relationship of the H plus ions to its pH. So 1 times 10 to the negative first, the pH is 1. 1 times 10 to the negative second, the pH is 2, and so on. And what you'll notice about this is how much of a jump that there is between each of the H plus ion concentrations. The pH scale is a log-based scale. So the pH changes by 1 for every power of 10 that changes in the H plus ion. So even though there's only a difference between 1 here, there's a difference between a power of 10 between these two. So it's a logarithmic scale. Here's a pH scale showing some common things that you may be familiar with, what their pH would be. So while we have neutral right here at -7, 1 times 10 to the negative 7th, that would be where you have equal numbers of hydrogen and hydroxide ions. Pure water is right at a 7. Milk is a little bit acidic. Blood is a little bit basic, but not by a whole lot. You'll find out in anatomy class how important it is to keep blood within that certain pH range, right around 7.3 or so. Household ammonia, which is a cleaner, and sodium hydroxide, which you'll be mixing up for the titration lab, are very basic. Vinegar, lemon juice, and stomach acid are very acidic, and then the hydrochloric acid is extremely acidic. So it just gives you a relative idea of different substances that are found on the pH scale. So what happens if we know the pOH instead of the pH? Well, the pH by definition was the negative log of the hydrogen ion concentration. So pOH is the negative log of the hydroxide ion concentration. At any point, you should be able to take the pH of a substance and add the pOH of the same substance together and get a total of 14. In order to calculate H plus from pH, so let's say that we are given the pH equals 6, and I want to know what is the hydrogen ion concentration. Well, this is how you're going to do that. You're going to take the anti-log or the inverse log by using the second and your log keys in that order, and your calculator may be a little bit different. Most of them are like this though, so the second key and then the log key to take the anti-log. Enter the your negative sign, the minus, and then the pH, and then the equal sign, and that will tell you what the hydrogen ion concentration of the substance actually is. Let's take a look at this example. It says the pH of human blood sample was measured to be 7.41. What is the H plus ion concentration for this blood? So things that we know that pH equals the negative log of the hydrogen ion concentration. Really bad bracket on that side. We know this information. Well, instead of calculating pH, we're going to be given pH, which is 7.41, and we are going to take that and use that to find the hydrogen ion concentration. Now, in order to get rid of this negative log on this side, what we're going to have to do is take, first of all, and divide both sides through by the negative. So we're going to take 7.41, divide it through by -1, divide the side through by -1, so that's positive. Then we're going to take the anti-log or inverse log of -7.41 in order to get the hydrogen ion concentration. So let's take a minute and throw that into the calculator. So I type in negative So what I'm going to put into the calculator is second log and then minus 7.41 into parentheses. And the answer that I get for this is going to be, let's see, the H plus concentration is going to equal 3.89 times 10 to the negative 8th molar. And that's a positive 3.89. We have two places in past the decimal point here for the pH, so we keep two places past the decimal point here for the H plus concentration, and that's how we do that one. So let's take a look at this next example. This is talking about the pOH. So this is the pOH of water in a fish tank. So we're going to write down pOH is equal to 6.59. What is the OH concentration for this water? So we can do this problem just like we did the last one, wanting to know the OH concentration. We're going to start off by putting in 0.659 as our pH, and that equals the log, negative log, of the OH ion concentration. Divide both sides through by a negative, get that rid of that. We're going to do the inverse log or anti-log of both sides. So we're going to take our calculators and we're going to type in inverse log of negative 6.59. So second log or inverse log of negative 6.59 into parentheses. And I find out that my hydroxide ion concentration is 2.57 times 10 to the negative 7th, and that would be molar substance. So that's how we do that. Now we can do calculations with pH and pOH, but we also have other ways of finding out if a substance is acidic or basic. We have things that we use in the lab called indicators, and phenolphthalein will be the indicator of choice that we're going to use in our titration lab. And what happens is that the substance exhibits a different color if it's an acidic or a basic solution. So the indicator that we're going to talk about, which is going to be the phenolphthalein, turns one color in acid and another in a base solution. So this just shows us that in an acid solution, the indicator will be a certain color, and in the base, a different color. There are other methods other than just titration that we can use as well. We can use pH strips, which we've used before in class, and that just tells us basically if it's acidic or basic. We can use pH meters. This is more like a pool test kit that you would see pH strips being tested. What we're going to be using is one that looks similar to this, and you'll use it connected to your calculator, and it will actually measure the pH value as you change the amount of acid or base in it, and you'll see that on your display on your calculator, as long as you use new batteries in your calculator and it has enough energy to run those devices. So lots of different ways we can test pH, lots of different ways we can find out if a solution is acidic, neutral, or basic. We're going to do some more calculations for practice, but in the lab, you're going to use an indicator, you're going to use pH paper, and you're also going to use your vernier pH meter to see what the pH level is inside of a solution while doing a titration. So a little bit of everything as we go on with chapter 16. And one last thing just to touch on, calculating the pH of a strong acid. Remember, the strong acids go to completion. So in order to get the pH of a strong acid, we just are going to determine the hydrogen ion concentration and then take the negative log of that to determine the pH. So it's really nothing new. So let's go ahead and take a look at an example, and this is found on page 533 of your textbook, and it says calculate the pH. So it wants pH of a solution that is 0.1 molar HNO3. And nitric acid is one of our strong acids, so we know that if we put 0.1 molar solution of HNO3, it's going to completely dissociate to 0.1 molar of H plus ions plus 0.1 molar of the NO3 ion as well. So because we know what its molarity is, that's its concentration, we can find the pH by taking the negative log of 0.1 molar. And if you take your calculator and type in negative log of 0.1 molar, you're going to find that the pH is 1, and that's our answer. So we can do this as long as we're looking at strong acids or a strong base and find the pOH.